All right, quick help honors. Are you ready? The inverse of sine, cosine, and tangent functions. This is 7.1. So let's just review some properties of functions and the inverses, okay? Notation. There's a couple of notations I want you to understand. F to the -1 power. Someone tell me what that is. That's right. That is the inverse of F, okay? This is inverse of F. So learning math is like learning a brand new language. If you don't understand, please ask. So number 1 says F inverse, okay, is composed with f of x. So this right here means it's a composition. So F inverse is composed with f of x equals to x for every x in the domain of F. And, this is a really important keyword, and. F is composed with F inverse of x equals x for every x in the domain of F inverse, okay? So what that is saying is in shorter language or in plain English, when I compose the regular and its inverse, they both have to equal to x for them to be inverses of each other, okay? So I take the regular, I compose the inverse, and I take the inverse and I compose with the regular. They both have to come out to be x, and the word is and. If one of it fail to equal to x, then they are not inverses of each other. That be okay so far? The domain. How do we find an inverse in algebra 2 trig? What did we have to do? Perfect. We switch the x and the y's, okay? So if you look at number 2, it says the domain of F is now the range of the inverse. Okay? That means I'm just switching the x and the y. Hence, the range of the regular F is now the domain of the inverse. So all that is saying that we're switching x and y. 3, the graph of F and the graph of its inverse are symmetrical or symmetric with respect to the line y equals x. What is that line, by the way? Horizontal? Up and down? Diagonal? Diagonal, okay? So if I were to fold on that line, they need to line up perfectly, okay? 4, if a function y equals f of x, by the way, by notation, anyone know what this even mean? Y equals f of x?
You mean like y equals y?
Yeah, y equals y, but why is saying y equals y is redundant? Why do you think it's saying that?
A lot of times what we can see, we'll see a lot of equations that say functions that say f of x, and a lot of times we'll see equations that say y equals x.
Okay, let me tell you the difference in two. If you see f of x or g of x or something of x, it's already a function. You don't have to second guess it. Does that make sense? If you see a y equals, that may or may not be a function. So this number 4 says if a function y equals, that means it can be anything. But the moment that you see f of x, that means that this is a function. Okay. So if a function y equals f of x has an inverse function, the equation of the inverse function is x equals f of y. What does that mean? What am I doing there? So it's what? Switching x for y and y for x. Then it goes on and said the solution, that means the answer, is this equation. What do you have to do after you switch? Yeah, do you have to go and solve? You must. So solve for y. So after you have switched x and y for x, you have to solve for y. Okay. All right, here we go. Complete this on your own and answer the questions on the right. So here we go. I'm going to ask you to graph y equals sine of x. I want you to go as far out as 2 pi to the right and negative 2 pi to the left. Go up as high as 1, as low as negative 1. Okay, so you and your team, graph it out. Make sure you make equal intervals for graphing. If you don't remember, just ask your peeps.
Over the summer, I was like, I'm never going to use this again. No.
So graph it out. Please compare that with your team, so that way you're not off track.
I know I did it right. It's chilling. Keep going.
Yeah, no, this one was like this.
Yeah.
Oh, wait, never mind. I answered my question.
In general. Okay.
Starts at 0, 0. So it starts at 0, 0 for sine, and then you go and divide this into 4 equal parts.
Oh, okay.
For sine, sine of 0 is what? Sine of 0 is 0. Sine of 0 is 0.
No, that's wrong. Oh my god. I am not eating.
All right. Don't forget to go left as well, okay? Go left 2 pi as well, please. All right, here we go. 0, 0. Pi over 2. What's sine of pi over 2? 1. What's sine of pi? 0. Sine of 3 pi over 2. Great. And then back at 2 pi is? Okay. Just because we stop here at 2 pi, does the function itself stop? No. Arrows. Is this an even function or odd function? Even or odd? It's odd. It's an odd function. What does that even mean, odd function?
It can be folded across the x and y axis at the same time.
Right. Reflected x and y. Or can we say it's reflected about the origin? That means I have a point in quad 1. That means I should have a point in quad 3. Okay. And then follow the pattern. Should you have really sharp highs and lows? Pointy, no pointy, okay? Because if you have points, like really sharp, like absolute value functions on these, it's going to be slightly wrong. Okay, let's go back and review. What is a one-to-one? Is sine, y equals sine of x a one-to-one function? What is that, by the way?
For every x value, there's a y value.
For x value, there's at least one y value? Or at most one y value? How about the other way around? What's a one-to-one? How is one-to-one different than a function? Okay, let's talk about the function first. What is a function? Okay, a function is for every input. You can only have at most one output. Do I even have to have an output? Do I even have to have an output? No. But if I were to have one, I would have at most one. That means I can't have two. That's a function. How is that different from a one-to-one function?
One-to-one means for every x there's only one y, and for every y there's only one x.
Correct.
If you turn it like this, would it be a function still?
Perfect. Nicely done. So remember, if you have a graph, okay, for a function, you just have to say, hey, it passes my vertical line test, right, class? So right now, is this a function? Yeah. But for it to be a one-to-one, what test are we using? Yeah. What's going on? Pass or not pass? No. So is this a one-to-one? No. Okay, so it's not a one-to-one. So the answer is no. Because your answer is no. We have to restrict its domain so it can be a what? A 1 to 1. Why is it important for us to have a one-to-one function to start before we find its inverse? What's the logic behind that? Why does f of x have to be 1-to-1 first?
Because if it's not 1-to-1, it's inverse of your function.
Yeah, so let's just take something simple. A problem. Is this a 1-to-1?
No.
No, right? Because passes different. So if it's not a 1-to-1, is it a function? Yeah, for sure. It's a function. It's not a 1-to-1. What happens when I take a non-1-to-1 and I turn it into its inverse? Is it a function now?
Not a function.
No. So that's why. It has to be a 1-to-1 first. Okay? So we have to restrict its domain. In your team, in your group, where do you want to cut this off? So we can have a 1-to-1 function for sine.
0 to pi.
So you and your team, what do you want to cut it off?
We just can't have the same line. I know,
Literally like everything is a little section.
how would you write? Describe this?
Negative pi
Oh, wait. Just way to write it. It's like negative, okay, so it's 0. Every, it's like x pi x minus like 1 half.
All right, Chase, you and your team, what do you guys want to cut off?
Yeah, what's that? Remember that? No? Remember that?
Okay, how about Mr. Summers' team? Joshua, what did you guys? Huh?
Half pi and then negative half pi.
Okay.
Yes.
So negative pi over 2 to pi over 2?
Yeah.
Why? How come you don't want to cut off from 0 to pi? It seems like a really nice number.
Because it won't pass the horizontal line test.
There's 0. Here's pi, right? Isn't that a nice number? Is that a 1-to-1? No. Okay, that's not going to work. So, you are now going to tell me that I'm going to cut it from here to here?
Yes.
Is that a 1-to-1? In theory, is that the only spot that's going to make it 1-to-1?
No.
No. Okay, it's not. But universally, back in the days before our parents or grandparents were born, all the mathematicians came together and they agreed that's the spot. Okay, so that's the spot. Here we go. So we're going to write. We have decided to restrict its domain from inclusive negative pi over 2 all the way to pi over 2. Okay. Then we are now going to define what an inverse of sine is. Inverse of sine, all we do is we switch x and y for x. But after we have switched it, just like all the properties up above, can I leave it that way? No, I have to go and solve for y. Gosh, how do you solve for y? Can I divide both sides by sine? I'm going to do it like this. Is that okay? No, that's sin. It's sinful. Don't do that. Yes. Take the sine inverse. It's like this. Trig functions like sine, cosine, tangent, you know. You can't just write the word by itself, okay? If you write tan without anything, it's like going to the beach and get a tan, okay? It's just like log and natural log, okay? If you write log by itself, does it mean anything? No, it's a piece of wood. Okay, in math, it doesn't mean anything if it doesn't have an input. So, sine by itself is sin, and that's sinful to do it, so don't do it. Okay, so sine of y. So to solve for it, we are going to compose that with arc sine is one of them, or we use sine inverse of x. Arc sine is okay too, okay? So you're going to see both. Arc sine and sine inverse. They are exactly the same. Now,
Which one we use on a test or we use on paper?
your book only used this,
Okay.
okay? But you can use whichever one you wish, okay? Now, I'm going to state the domain and range of sine inverse. What is the domain of sine inverse?
-1 to 1.
Hey, how'd you get that?
It's the range of the other function.
You guys agree it's the range of my f of x?
Yes.
Yep. -1 to 1. What's the range then of this inverse function?
Negative pi over 2 to pi.
Yeah, didn't we cut its domain earlier? So isn't the domain of the regular restricted? Is the range of the inverse? Yep. I'm also going to spell out the quadrants, okay? What two quadrants? Because sometimes I mention quadrants and sometimes I may mention the range. What two quadrants is sine inverse in? Quadrants. Where, bless you. Where's pi over 2 at? Top, bottom, right, left?
Top right.
Top. Yes or no? Is that pi over 2? Where's negative pi over 2 at?
Bottom one.
Bottom. So what two quadrants is sine inverse in?
1,
1 and
4.
4. Quadrants is 1 and 4. So sometimes I mention the quadrant because it's just easier to say, and sometimes we mention the negative pi over 2 to pi over 2 because it's relating back to the circle. Okay? So now we're going to graph them both together to see if it's symmetrical about anything. I'm going to graph the original one in blue. Okay? So remember, we cut it off from negative pi over 2 to pi over 2. So that's all I need. So here's negative pi over 2 to pi over 2. Okay? I know eventually I'm going to have to graph out its inverse, so I might as well label them the same. Now I have to put in 1. Where would I put 1 in if I started with pi over 2 already? How is 1 related to pi over 2? Or where should I put it?
It's smaller than pi over 2.
It's smaller? How small? About? Approximately.
About
1/3 to 2/3?
1/3.
1/3 of its distance or 2/3 of its distance? What's pi about?
3.
Yeah, 3-ish, 3.14 divided by 2, that's like 1.5-ish. So 1 is 2/3 of its way. Would you agree? Yeah. So I'm going to go in and put 1 right there. The reason is that I need to graph both of them, and I want to make sure I'm okay. Okay, so here we go. Sine is 0, 0. Okay. So that's 0, 0. At pi over 2, sine is what?
1.
1. Okay, so pi over 2, comma 1. At negative pi over 2, sine is negative 1. Negative pi over 2. Okay. And then we're just going to sketch it out, but only the restricted part, because the rest of it is not a function. I'm sorry, not a 1-to-1, so we don't need it. So this I'm going to label y equals sine of x. But now I need to graph its inverse. I don't need to do any work, really. What do I need to do? All I do is what? To graph its inverse. Flip what?
Flip your just the line or the function.
You're right. I'm going to flip it. But flip it how?
Cross the origin.
Yeah, I'm going to cross the origin. Or can I switch what? The xn? Why? Don't I have 3 points on there? Can I just switch those? Yeah, 0, 0 stays, right? But pi over 2 comma 1 is no longer pi over 2 comma 1. Is now 1 comma pi over 2. Okay. Then negative pi over 2 comma negative 1 is now just negative 1 comma negative 1 comma negative pi over 2. Now, curvature. How am I curving these 3 dots? It's not a line. Which way are you curving? Hugging the y-axis or hugging the x-axis? Yeah, you have to look at the other one and see. Okay. Can you guys see that? Okay. Now, there's a line in your definition of inverse. What line is this? Right. If I'm a perfect person and I graph this out perfectly, does it look like it might be symmetrical?
Yeah.
Yeah, all right. So that's really what it means to be an inverse in its original. All right, now you and your team go do the same thing for cosine. Graph it 2 pi to the right and 2 pi to the left.
Why are the quadrants on the first one 1 and 4 when it's 1 and 3?
1 and 3? No. When you graph it out, sorry, it's frozen. Okay. When you graph it out, can you see that it's on the left and right of the x and y plane, which is not the same as a unit circle, right? In the unit circle, pi over 2 is above, right? Negative pi over 2 is the bottom. So that's why it's in quad 1 and 4. Did I? Okay. Okay, so you and your team graph out cosine. And then answer the question to the right. Decide where is a good spot to cut off, by the way. Talk it out. Convince your team that you're right.
What if it was negative pi? Pi to 2 pi? And we just set the entire thing up like it's like cosine. In Malaysia? Yeah, I was gonna do that. Yeah, 0 pi plus 2. I was gonna do like pi to 2 pi, so it's positive, but doesn't matter. So it's 0 to pi is just square. Is it next one, right?
Cosine starts where? 0, comma what?
1.
1, okay. So I'm just gonna, it's cosine even or odd? Bless you.
Even.
That means what?
It reflects across the y-axis.
Yep, so all I need to go is go left and make the same exact dots. Okay. Even means reflected about the y-axis. That's right. Okay. All right. So the answer to in the box is cosine a 1-to-1? No, because you said no. We have to restrict its domain so it can be a 1-to-1. Where did you restrict it?
0 to pi.
0 to pi? Let's cut it to see if it's right. Here's 0. Here is pi.
What if we did pi to 2 pi?
Okay. Is that 1-to-1 first before I move and then cut it from? Okay, so another one is more.
That it just looks like the sine one.
So would you say it's pi? Is pi to 2 pi okay too? Yeah. So yes, any one of those can be okay except universally. Guess what they agreed to?
0.
Why is that, by the way? Why did they pick 0 to pi?
I don't want to confuse it.
It's just closest to the origin.
Closest to the origin. And also, the number 0 is so nice. Why? Isn't it? It's like the best number ever.
It's just easy to work with.
Yes, it's easy to work with. A lot of times it's like mental math when you plug in 0, right? So that's why. We love it. Okay. So we're going to cut it from, oops, I did not mean to have highlighter on there. Okay. 0 to inclusive pi. Okay. We are going to define, graph it out, and we're going to call it a day. Here we go. Definition of inverse of cosine is, tell me, x equal to?
Cosine y.
That's right, cosine of y. Can I keep it in that form?
No.
No, solve for it. Y equals f inverse of x, which is
Cosine inverse.
cosine inverse of x. Would it be okay if you use art? Yes, it's really up to you. I need 2C in there. Okay, let's go over the domain of cosine inverse. What is the domain of cosine inverse?
What's negative 1?
Domain of cosine inverse is the range of the regular, right? What's the range of regular?
0, 1.
Yeah, -1 to 1. What is the range of cosine inverse? Where do we cut it off? 0 to pi. And I'm also going to mention quadrant, because oftentimes I'm just going to say, oh, what quadrant is cosine inverse in, okay? So what quadrants are we talking about? Okay, so where is 0 is right here, right? On my unit circle? Is this pi over 2 right here? And this is pi? So what two quadrants are we talking about? 1 and 2. Okay. By the way, none of the inverse functions is in quad 3. So just keep that in mind. Okay, so it's cosine x or y. X. They will always have one quadrant that will make it positive and one quadrant will make it negative. So guess what? In quad 1, all of the functions will always be in quad 1 because in quad 1, everything is positive. So now it's really quad 2 or quad 4, right? Quad 2, x is going to be negative. Would you agree? Quad 4, y will be negative. So it depends on which one we're talking about. So, but nothing is in quad 3, okay? All right, let's graph this out, and then this is it today, okay? I'm going to start with, we said 0 to pi, so here's pi. Here's 0, here's negative pi. Here's positive pi above, negative pi in the bottom. If I have to put a mark for 1, how far out, what's the proportion from 0 to pi that I need to go? 1/3, so a third of his distance. So 1 is right here, negative 1's right here, positive 1's right here, negative 1's right here. All right, here we go. For regular cosine, 0 is 1. Am I right? Yeah. So 0, 1. Pi over 2, staying at 0. Is that okay? And then at pi, cosine at pi is 1 or negative 1? Negative 1. Okay, so right there. Hug it. Okay, so here we go. Let me just make this dot again. It's not a cute dot. Okay. So pi comma negative 1. All right, let's graph its inverse. I'm going to do it in red. So the blue is y equals cosine of x. How do we make an inverse function from what we already have? All you would do is what? That's right. So 1 comma 0 is my first dot. Here's 1. Here's 0. Okay. What's your next dot? 0 comma pi over 2. So pi over 2 is smack center. So 0 comma pi over 2. What's the last dot? Negative 1 comma pi. Pi is all the way to the top, so here we go. Negative 1 comma pi. Oh, it's bubbly. Thanks, Ben. Hugging. Hugging x or hugging y? Why? Like that? Okay. Okay. If I were to draw in, and assuming I'm a good grapher, a line called y equals x, should it be symmetrical? Okay. Hopefully, if you're a good grapher. Obviously, graphing by hand is never going to be perfect. But if you can see that it might be, well, that's good enough. That concludes our day. No phone, but please talk to your friends.